Okay, so I've got linear, I've got trigonal planar. That's going to be sp2. I've got tetra, which is going to be sp3. And then I've got my expanded octet, which has a trigonal bipyramidal, which is sp3d, and octahedral, which is sp3d2. Does that make sense? So if this is your electron geometry, this is your hybridization, period.
So how do you know like which bonds or like which like elements are the ones that are have like the 5 bonds, or that's what's most confusing to me with like
the drawing?
SPD. Yeah, like how does one have because I know it's the 5.
So generally when we're talking about these properties, we're usually talking about the central atom, right? So when we're talking about the central atom, we're kind of assuming that we're talking about the one in the middle, but when we get into more complicated molecules, there can be multiple central atoms, right? So we could talk about the geometry around any atom, right? Let me give you an example. So acetic acid, we draw the structure for this guy. We'll have, let's see, cool, I did it. So if we're looking at the Lewis structure for acetic acid, right? If we look at this as our first atom, right? What's the geometry here? The electron geometry. Tetrahedral, right? What about here? Trigonal planar. And what about the electron geometry here? Tetrahedral. Right? Now if we're looking at the molecular geometry, right? Here, this guy has the same molecular geometry as it does electron geometry, right? Because there's no lone pairs. You with me? So 1 and 2 are the same as the electron geo. Cool?
Yes.
What's this guy though for the mole geo? It's bent, right? It's bent because it's still 4 total attachments, right?
Oh, because it has 2 lone pairs.
Exactly. So we have bent. Does that make sense? So we're usually talking about the central atom, but especially when you get into organic molecules, there's not usually a central atom. You could talk about any of the atoms as being central, quote unquote.
Okay.
Does that make sense? So if we know the electron geo of each one of these, we can talk about the hybridization of each one also, right? So tetrahedral has what hybridization? sp3. Trigonal planar, sp2, and tetrahedral, sp3, right? So in the same way that we can talk about the geometry around each one of these guys, we can also talk about the hybridization around each one. Does that make sense? So yeah, I don't know why they don't make this nice table because it's so much easier to understand this way, right? But the things that you already know about linear geometry are because of the hybridization, okay? So this isn't something new, it's just an extra level of detail to explain why linear is a possible shape and how it optimizes the energy of the molecule, right? Because the whole thing with Lewis structures is we're trying to get the lowest energy structure, right? So one of the ways that we do that in VSEPR theory is by maximizing the distance between these groups, right? So when I draw a tetrahedral molecule and I'm lazy, right? What does it look like the angles are there that I drew?
90.
Yeah, but what are they actually? That's another thing you gotta know.
The 109.
Mm-hmm. Yeah, so they're approximately 109.5 degree angles, right? So the question is if I have this s orbital and these really ugly, sorry guys, I'm such a bad drawer, and these 3p orbitals, right? How am I supposed to get 195 degree angles, right? Because this essentially has, oops, I'll draw it up here. This essentially has one atom coming out at me and one atom going back into the page, right? So this wedge means that it's coming out of the page. This dash means that it's going back into the page, right? So it's a terrible drawing, but hopefully you guys can see that these guys have non-axial components, right? So does this guy. Does that make, do you know what I mean by non-axial?
No.
Okay, so axial components would be ones that point directly along the axis. Does that make sense? Non-axial components are ones that are outside of the axis. So they're not directly on the axis, they're a little bit off from the axis. Does that make sense? So the only way that you can get this shape that is slightly off axis is by taking these guys and mixing them together. Just like you would mix together paints to get a different color, right? Because these only have axial components, right? So in order to get non-axial components, right, components that are off the axis, we have to mix these guys up. I'm gonna switch to my